Okay, good morning everyone. So this will act as a correction video for one I recently uploaded under definition of derivative. So we have here that this is the video and Sir or lecturer Bax indicated command on the effort. Keep it up, however, let me point out that you're being differentiated by rule and I'm using definition of derivative. The definition requires that you differentiate the function using the limit definition. Limit h approaches 0 of f of x plus h minus f of x divided by h. Alright, now this, before I get into doing this here, this just goes to show how quote-unquote lazy online learning has made me, because looking at it, all I focused on was just simply answering the questions as you see here. Like I just said, you know what, let me just get this over with as quickly as possible. And when I think of it, if this was actually an exam or of some nature, I would have been losing a lot of marks because I didn't actually follow the guidelines that was provided. And this is also a time where I've been looking at what's going to happen come, let's say, probably in September when university reopens. Because when I think of it, when UG reopens, most of the lecturers will be probably smiling. And I say this probably as a joke and also very seriously, because for this first year, we're generally having it easy based on all the advantages of actually doing it at home. But when we get back to university and we have to go through the actual turmoil of being in a university environment, I don't think we want to be viewed as a laughing stock based on how stressful that can actually be for most of us. So maybe it's best that maybe all of us just consider that yes, we are at home, but we need to actually dedicate time and patience to actually doing the work that we actually have to do. Because I know some lecturers when we come back, they are going to just laugh and say, first year was your year, and now second year is our year. And it's not going to be that the classes are actually harder, it's just that we had the benefits of actually being at home. So moving forward, I'll actually slow down and not move so fast as I go through this. So this is irrelevant. This is what I would have to do. This is my new workbook. Now, I always have this mysterious persona about me because I always say things but never actually complete it. So Tamishwar and Sir Nanjam, you're the guys that I'm actually making these videos for primarily as I go through this. So I hope you guys are actually putting in some time in your work, in your other studies as well, and don't let the online frustrations get to you. And on that note, for anyone that's about to watch this video, in differentiation from first principles, which is going to be the definition of derivative, this is going to be a very long video because of the steps that goes into solving these questions on the first principles. It's ridiculously long and complicated. And I'll also show you a concept. I don't know if it was done in a tutorial because I haven't had the opportunity to be in one as yet. I need to try and make more time for that, where we look at delta x is approaching 0. So, starting off, y is equal to minus 2x plus 5. So, we start this long, probably 1 hour journey now. Make this smaller. So, here we have it. Y is equal to minus 2x plus 5. Like I said, I'll be going through things as slowly as I possibly can to ensure that I don't make unnecessary mistakes. So, here we go. dy upon dx is equal to the limit as delta x approaches 0. Now, this delta x here is the same as h. However, from the research that I've actually done, whenever you're given y, you use delta x is mapped onto 0. So I guess I'll be applying that concept here, because I do understand that for one of the things we may be assessed upon is identifying errors throughout the problem. So I don't know if we may be faced with something like this here. So for the sake of ensuring that you guys are adequately knowledgeable of what may come, I'll be using the delta x mapped onto 0 as I solve for whenever y is the subject of the equation. So I'm not going to write out the formula. I'm just going to move on to the next line, which is minus x plus delta x plus 5. So you should already identify that this here is actually the x plus h. Good. Oh shoot, I made a mistake. This should be 2 in front. So this is minus 2 x plus delta x. Close your bracket plus 5. And then it's minus f of x. I have my minus sign. You use your bracket, which is minus 2x plus 5. Close my bracket. And now since we made use of delta x here, you're using delta x in the denominator as well. Alright, so let's just move on to saying the limit as delta x approaches 0 of, again I'm just going to write this out, expanded and multiplying this. So I'm going to know, so what I know is I have minus 2x squared plus just a moment, not 2x squared, what am I doing? I need to just calm down a bit. Alright, I have to edit this part out. Boom. Alright, so what we're going to have now is multiplying minus 2 by everything inside here. So we have minus 2x minus 2 delta x plus 5 plus 2x minus 5. And this is all being divided by delta x. Yeah, I went to sleep like 3 p.m. I had to get up very early to help my family with some work. Haven't eaten since yesterday morning, so yeah, that's a thing. So let's cancel this out, cancel this out. So that's it left me with is minus 2 delta x, all being divided by delta x. X and delta goes, leaving me with minus 2. Alright, so I believe you should always just write out your answer, because dy upon dx is equal to minus 2. Alright, next one. Minus 4x minus 2. Alright, so what is it given as though? F of x. So for f of x, I'll be using the h concept that we've been using thus far. So f of x is equal to minus 4x minus 2. So dy upon dx is equal to the limit as h approaches 0. So whenever it's f of x, I'm using h. So writing this out, I'll have minus 4 of x plus h minus 2 subtract, open bracket, minus 4 minus 4x minus 2 close bracket. And this is all being divided by h. So next up you'll have to expand. Oh my gosh, just thinking about how many lines will have to come soon into play. Alright, so we have minus 4x plus 8 plus 4h. Alright, plus 4h minus 2 plus 4x plus 2, all to be divided by h. So, cancel out the 2's, and we get rid of the 4x's. 4x's. Alright, so this is the limit as h approaches 0 of 4h being divided by h, which is going to equal to minus 4. So dy upon dx is equal to minus 4. And this is number 2. Number 3 now. Yes, the long lines. Y is equal to 4x squared plus 1. So y is equal to 4x squared plus 1. So dy upon dx is equal to the limit. As I said before, whenever I see y, I'm having delta x. This maps onto 0. So what I have here now is 4 in bracket x plus delta x squared plus 1 minus 4x squared plus 1 close bracket. And this is all going to be divided by delta x. Alright, so I'll actually write this line out so you'll see exactly what happens when you multiply this bracket, or expand it I should say. So this is the limit as delta x approaches 0. So you're going to write your 4 in bracket. Next you're going to have x squared plus 2x delta, I don't know why I did that, delta x close, no, not close brackets yet, plus delta x squared close bracket plus 1, oh boy, minus 4x squared plus 1 close bracket. Yeah, I'm gonna have to figure out a way to write all these long lines coming out without having it so clustered. Alright, so you'll have x squared plus 2x delta x plus delta x squared, which is then, this needs to be in a bracket. The reason why it needs to be in a bracket is because it looks as though it's x squared, but this is actually the whole thing, which is delta x being squared. So it's not x squared alone, it's delta x that's being squared. So you have minus 4x squared plus 1. Alright, next line. I'm going to try and write smaller now. dy upon dx equals the limit as delta x approaches 0 of 4x squared plus 8x delta x plus, in bracket, and all. You should practice doing this as well whenever you have these type of situations, which is now going to be added or subtracted. This is the problem. 4x plus 1, so this is going to be subtracting 4, nope, what is it, plus 1. This needs to be plus 1. Alright, so this is plus 1 minus 4x squared minus 1. This is all being divided by delta x. So the 1, we get rid of that 1. This is going to get rid of that. And also remember, when you're working these problems, your f of x component will always subtract something in your expansion. So always keep that into consideration. So now Next line, the dy upon dx is equal to the limit as delta x approaches 0 of 8x delta x plus delta x squared, all being divided by delta x. Now, next step is generally straightforward. You just need to factor out the delta x, so the dy upon dx is equal to the limit as delta x approaches 0 of delta x bracket 8x plus delta x being divided by delta x. This goes, leaving me with 8x plus delta x. As a result, we have dy upon dx is equal to the limit as delta x approaches 0 of 8x plus delta x. We know that delta x is going to be 0, so we have our answer here as, not our answer, so it's 8x plus 0. So my dy upon dx is equal to 8x. Next question will be number 4. Wow. Alright, number 4. f of x is equal to minus 3x squared plus 4. Number 4, f of x is equal to minus 3x squared plus 4. So since we're having f of x, it means that instead of delta x, we're using h. So dy upon dx is equal to the limit as h approaches 0 of minus 3 of x plus h plus 4 minus 3x squared, put my square there, plus 4. Wow, alright, so here we have that. So just make sure I have everything here. Minus 3 of x plus h squared plus 4 minus 3x squared plus 4. I am not going to expand it out. I am just going to write what it is after expansion and multiplying by the minus 3. H approaches 0. So what this is going to give me is minus 3x squared, not plus, come on, keep your head on, to be a minus 3x squared minus 6hx plus 3h squared. So I could probably bring this out. Now you see that I don't have this in bracket because this squared belongs to h, not to 3. So 3 has a power of 1. H has a power of 2. So this is going to be plus 4 plus 3x squared minus 4. And this is all going to be divided by 8. So 4, 3 goes with that 3. So let me start doing what I always said I should do. So anything that I have remaining, I put an asterisk over. This helps me realize that, okay, this is what I still have and what I need to work with. The dy over dx is equal to the limit as h approaches the 0 of minus 6hx plus 3h squared, all being divided by h, equal to the limit as h approaches 0. This is going to give me h on the outside minus 6x plus, alright, so I'm trying to squeeze it in and it's not working out, so let me just do it once more. Scroll up a bit, get rid of this. Alright, so dy upon dx is equal to the limit as h approaches 0, so I'm not going to do that. I'm just going to do the factoring component down here. So what's similar between the two is a 3. I'm write it as negative 3, negative 3h, negative 3h of 2x. To get the positive, it's going to be minus h. If I do that right, positive as the answer, right? Let me just check something quick before I move on. Alright, so plus 3h. No, this should be minus 3h squared. Wow, going back and realizing that you have a mistake. Well, let's put this here now as positive. Now if I actually had to be doing this on the pro level, I would actually just edit this part out. But again, this is just like me and you working it together if you were actually in the online space. So that's why I don't really edit out any of the mistakes that I actually make. So this is just a whole learning experience by itself. So moving on, the h cancels h. So dy upon dx is equal to the limit as h approaches 0 of minus 3. Let me just expand. So this is going to be minus 6x minus 3h, which is going to be equal to minus 6x minus 3 times 0 gives me minus 6x. So this tells me dy upon dx is equal to minus 6x. Alright, so I guess we now move on to the lengthy problems. From number 5 to number 10, my gosh, they're going to be long. Alright, so y is equal to minus 4x squared minus 5x minus 2. So you know I'm solving for dy dx. I'm just going to say this is equal to the limit because I know how lengthy this is going to be. Oh boy. Alright, let me just use h in this problem because it's going to be a lot of lines to write out. It's going to be very jumbled if I write it out the other way. So this is minus 4 of x plus h squared minus 5 of x plus h minus 2. So in bracket I have minus 4x squared minus 5x minus 2, which is all being divided by h. See if I had to use delta x now. It would have been very lengthy. So is equal to the limit as h approaches 0 of, alright, so I'm gonna skip a line. Yeah, I'm gonna skip a line. So this is after you expand here and then multiply by minus 4, so it's gonna be minus 4x squared minus 8hx minus 4h squared minus 5x minus 5h minus 2 plus 4x squared. Oh, come on, wake up already. Minus 4x squared plus 5x plus 2, which is being divided by h. This cancels this. 5 cancels that. X squared. Yeah, so that's one thing I always look for when it comes to this particular step. Whenever I am going to cancel out, I make sure I look back at this line and okay, this doesn't look right. I don't need to cancel everything out here. So what am I missing? And then I go ahead and cancel. So what do I have left remaining? This, and this minus 8hx minus 4h squared and minus 5h. So the limit as h approaches 0. So this is minus 8hx minus 4h squared minus 5h, all being divided by h. Okay, so this is equal to the limit as h approaches 0. We factor out h of minus 8x minus 4h minus 5, all being divided by h. So I'm going to move ahead now and substitute in 0 for wherever I see h. So this is equal to minus 8x minus 4 times 0 minus 5. This is equal to minus 8x minus 5. So dy upon dx is equal to minus 8x minus 5. Alright, how much more? Is this one number? 4 more. 4 more? No, I do number 6. No. 3x squared plus 3x plus 3. Alright, I guess I'll use delta x for this one. So, man, did I make a mistake with something? No. I'm going to use delta x for this one. So y is equal to 3x squared plus 3x plus 3. Alright. Alright, let me zoom out. Good. So, let's begin. So dy upon dx is equal to the limit as delta x approaches 0 of 3 in bracket x plus delta x squared plus 3 open bracket x plus delta x plus 3 minus in bracket 3x squared plus 3x plus 3. You ever been doing math? I was like, oh my gosh, I wish I could just be over with. Shoot, this is delta x. Yeah, sometimes it really drains you having to write all of these lines, but it's part of the learning process and also the examination process, so that's why you need to practice it. Alright, so for this here, it's going to be a lot to write this all out, so if let me just try and make this smaller, because when you see you put in the delta x, it's going to take up, it's more than h of course, it's going to take up more space. So the limit as delta x approaches 0 of, again, I'm not going to expand it out. I am just going to write it. So here we go. 3x squared plus 6x delta x plus, remember that is going to be delta x all squared, so this is delta x all squared plus 3x plus 3 delta x plus 3 minus 3x squared minus 3x minus 3. Yes, it all fit. If this was an edited video, you'd have seen balloons showing up on the screen with saying congratulations to me, because yeah, so this goes 3x 3x 3. Yeah, so this is exactly why when I write in a book, I always do this. This is what's left. Alright, so I have 6x delta x squared and 3 delta x. So I'm gonna move. Alright, so for persons that probably won't see it, limit as delta x approaches 0. So this is gonna be 6x delta x plus delta x squared plus 3 delta x, all being divided by delta x. And yeah, this happens when I actually am hungry and tired. I just like changing up my voice to make things seem fun. So I try to stay focused. So this is delta x of, what did I do? Delta x of 6x plus delta x plus 3, all being divided by delta x. Anyways, so this goes to this. So, well, I think I write it right at the bottom here. The limit as delta x approaches 0 of 6x plus delta x plus 3. So I know that I'll have to substitute 0 for where delta x is. So this is equal to 6x plus 0 plus 3. Thus my dy upon dx is equal to 6x plus 3. Let me say it right. Okay, so these are the demons. Okay. That's why I really appreciate knowing the rules. This is so much working. Oh my gosh, it's so much working. Alright, number 7. Alright, so alright, let's wind up. Alright. Number 7. Y is equal to the root of minus 3x minus 5. Y is equal to the root. Alright, root of minus 3x minus 5. Can I switch this layout? Alright, great. This is going to be a lot of writing. Alright, so if you're looking at this video and this is the first time that you're going to do it, take a short break, stretch, just press pause, relax, because this is going to be one interesting journey. Right, I had my break, so let's go. dy upon dx is equal to, since it's y, I'm going to use the limit as delta x approaches 0. Alright, I'm going to write the first line only, because I don't want to jump into the next step. So, since we're going to use x plus, alright, so let me write it here first. It's f of x plus delta x minus f of x. You need to remember that as you work this problem from the beginning. It's your savior. So, it generally means that we are having to write. Yeah, we're gonna have to write the wherever we see x, we're writing it as delta x. Alright, so let's go now. Alright, no more stalling. Let's get this over with. So this is minus 3 of x plus delta x, close bracket, minus 5. Make sure you draw your whole line there. Now, minus f of x, which is going to be minus, open bracket, the root of minus 3x minus 5. I got fancy up to 5 a little bit, close bracket. And this is all being divided by delta x. Now, in order for you to solve this problem, you need to use the conjugate of the numerator. Now, to explain this, I'm just gonna say con. Alright, so to explain this, con over con, if we cancel it out, is equal to 1. So what you're about to do, or what I'm about to show you, is just writing the conjugate so that I can actually solve this problem. And since it's going to be the conjugate divided by the conjugate, the result is going to give you 1. This goes back to algebra and surds. So if you don't remember that, you should go ahead and practice some surds so that you could actually have this done. I actually have to change my whole seating position just for this problem. Alright, so dy upon dx is equal to the limit as delta x approaches 0 of, I write all of this back, root of minus 3 open bracket x plus delta x minus 5. It's a little gassy right now. Okay, minus a minus 3x minus 5, which is all, of course, rooted, and this is over delta x, which is going to be multiplied now by the conjugate of this. So what you do is very simple. You write back what's in front, which is the root of minus 3 open bracket x plus delta x minus 5. Make sure I have my bracket here. Good. Now because of the conjugate, the sign, which is straight between them, goes to the opposite sign, which is net. So since this is negative, this is now positive of, what do you have there? Minus 3x minus 5. Now, whatever's at the top here, you're going to write it at the bottom. So you have the root of minus 3x plus delta x minus 5 plus the root of minus 3 minus 5. So if I actually divide this out, I'll get 1. Now, remember it's only for manipulation's sake. So I'll just take a simple opportunity to just remind you of something. A minus b and a plus b is equal to a squared minus b squared. Now, for your own mental sake, you will need to start using the rules that you were given, because if you work that out, you'll be writing for so long that you will get fed up. So, what do you do? Based on this rule, this is for the first one, this is for the second one. The easiest way I could tell you, because when you actually do the complete expansion or the multiplication between these two, put it in bracket for you. When you multiply these two that I have here in the standard bracket, the middle terms will cancel. That's what happens when you conjugate. Now, something else to take note of is that root signs are involved here. So when you actually have the square root of anything, and it's raised to the power of a square, the result is whatever you have underneath the square root. Remember that. It's going to save you a lot of time working these problems out. So, based on this rule here, the first needs to just work with the first, the second works with the second. Look for similarities. Whoever is similar here goes with that, whoever is similar here goes with that. Remember this concept here from laws of indices. If you have a root of anything and it's raised to squared, the square cancel out the square root, leaving with just this here. Of course, this only applies under this. So there are other concepts to actually pay attention to when you work this out. So make this x better. dy upon dx is equal to the limit as delta x approaches 0. Alright, so if you apply what I just mentioned, your life looks very easy. So I just write back this that I have in front, which is going to be the root. Sorry, not a root, because I got rid of the root sign. Root sign is no more because it's squared. So this is going to be minus 3. I'm going to expand, right? So minus 3x minus 3 delta x minus 5, right? Which is now going to be subtracting. No? Okay, so I'm expanding. So this is plus 3x plus 5. I did it too large. Get rid of this. You come back here. Alrighty then. So, after doing all, oh shoot, there's something important that I need to write here now. After doing all of this fanciness, you just have to write back these two without the root symbol. Alright, but this denominator is going to be, oh my gosh. Alright, this denominator is supposed to be a friend. So, I have here delta x bracket root of minus 3. Should I? Alright, minus, I'll leave it how it is. Minus 3x plus delta x close bracket minus 5 plus the root of, yeah, you see that time what is the writing? Minus 3x minus 5. The writing is a lot to take in. Alright, so let's swipe. Alright, so something to actually take note of, this delta x by itself is going to be something, I'm going to show you something else in the next problem that you could probably do at the very beginning that's going to help you tremendously when it comes to solving, no, it's not for this one. It's not for this one. Alright, but you could do, there's a few tricks you could actually do, but alright, let me just stick to what I've done here. So this is minus 3 delta x, all being divided by delta x, in bracket the root of minus 3, open bracket x plus delta x minus 5 plus the root of minus 3x minus 5. The delta x tells that bye-bye. So in my next line, what I'm left with is, alright, so I'm just going to start substituting the delta x is mapped onto 0. Yeah, it's the right end. I need to focus. Alright, so, yeah, this is where things become peaceful. This is where things become very peaceful. Alright, so what I have now is minus 3 all being divided by the root of minus 3x plus 0 minus, I have to go back over and make sure I actually have this written out how it's supposed to be. This is what you have. So I could actually write this right across here, which is minus 3 over minus 3x minus 5 plus the root of minus 3x minus 5. Alright. Yeah, this is this. And like before, they are both similar. If they're both similar, all you need to do is simply write them as is. But again, these are not multiplying, they are adding. So it's like one of the things is 1 plus 1. Again, this goes back to thirds. So my dy of 1 dx is equal to the 3 being divided by 2, the root of minus 3x minus 5. And you're finally done. As I said, these problems tickle your fancy. Whew, alright. So I love, alright, I have more enough pages. Number 8. F of x equal to 4x minus 5. Alright, so as I work this one out, I will focus more on. I think I should probably write it out since I'm using h since it's f of x. Alright, so here we go. F of x is equal to the root of 4x minus 5. So dy upon dx equal to the limit as h approaches 0 of minus, no, it's minus, not minus, what am I doing? This is root of 4x plus h, make sure this is going out, minus 5, minus, open bracket, root of 4x minus 5, close bracket, all being divided by h. Well, you know the magic happens in the next line, so let me just write this small one time. Limit as h approaches 0 of, write back what's here, root of 4 open bracket x plus h minus 5 minus the root of 4x minus 5 being divided by h, which is going to be multiplied now by root of 4 open bracket x plus h close bracket minus 5 plus, now there's a conjugate, the root of 4x minus 5 all being divided by whatever is here, the root of 4 of x plus h minus 5 plus 4x minus 5. Now, as I'm doing this here now, I just want to point something out again to persons. I'm not an expert at calculus. I literally spend time sitting and looking at videos and learning to work things out. So I'm still wondering what grade I'm going to get at the end of this course. So, with that being said, let's jump back into the fun stuff. Easy peasy lemon squeezy, no headache, you get it out of the way. So, let's go. 4 open bracket x plus h minus 5 minus open bracket 4x minus 5. You see why these brackets are so important? Put it back here just for the sake of it. Yeah, I should really emphasize on this. These brackets save you a lot of problems when it comes to this particular area. But with practice, you remember that you always have to be canceling that component there. So you'll know what to do in time. So what I have here now is, oh shoot, what am I doing? I need to put this at the bottom. H open bracket root of 4x plus h minus 5 plus the root of 4x minus 5. Close this as a bracket. Alright, so with that being said, what I have is 4x plus 4h minus 5 minus 4x plus 5. And isn't it lovely that you have to do all of that just to reach here? It's very lovely, isn't it? Again, when you learn the rules, you're like, why did I have to go through all this torment? Why? It's so much, my brain hurts. Yeah, even to this point, differentiation of force principles, it's just so long. Alright. Alright, outside of that, limits, I don't think I'm going to make any video for limits because that's yeesh for me. That's really yeesh for me. I mean, I could explain it a little bit, but I really can't explain the entire thing. like how a lecturer would probably be able, or should be able to break it down, I should say. But limits is, you gotta know the stuff. That is the truth. You actually gotta know how to work with limits so that it's manageable. Did I? No? Did I do something wrong here? Did I do something wrong here? Alright, let me just pause for a moment. I'll go back to my working. Nah, everything's good. Everything's good. Just processing too much. I need to get something to eat soon. Alright, good. So since we're here, let me just write this out now. Limit as h approaches 0 of 4 over, I'm going to substitute in 0 now, the root of 4x minus 5 plus the root of 4x minus 5. This is going to give me 4, like before. This is saying 1 of 1 4x minus 5 plus another 1 4x minus 5. So it gives me 2 4x minus 5. 2 ones 2, 2 twos 4. So this gives me now that dy upon dx is equal to 2 being divided by the root of 4x minus 5. 52 minutes. Alright, next. I have to check this here to make sure. Alright. Where am I? Alright, what's next? Oh, 1, y is equal to 1 divided by x plus 2. Y is equal to 1 being divided by x plus 2. Alright, so these are... Alright, let me show you the trick that you'll need to apply for this here from the inception. Delta x not down to 0, so the limit. So this is 1 being divided by x, x plus delta x plus 2, which is going to be subtracting 1 over x plus 2. This is all going to be divided by delta x. Now, because our division is so much of a pain, division is such a pain. Alright, so this here at the bottom, I'm just going to write it as delta x. Now, this here being dividing by delta x, what I will do is I'll put it as 1 over delta x. And what I'll also do is I'll write it in front of everything. So, what does that actually mean? Before I move on to doing the numerators, dy upon dx is equal to the limit as delta x approaches 0. And what you do, 1 over delta x. Do that and save yourself the headache that comes if you don't, of having to always remember that this is still at the bottom when you're actually solving. Alright, so moving on now, so I have 1 over x plus delta x plus 2 minus 1 over x plus 2. Remember I moved the delta x out in front, right? So this is now, line is too close. So you work your fractional component out now. Alright, exponent, measure this. Alright, so, alright, should I bracket it or not? Alright, let me bracket this. Alright, so this is x plus 2, x plus delta x plus 2 plus. So what this gives me here now is x plus 2. And when I work this here out now, I'm going to have minus x minus delta x minus 2. Yeah, so when I do this with LCM, it leaves me with this. When I do this with LCM, it leaves me with this, but I must pay attention to my sign. So I just wrote that out. If you notice already, bye bye. These are gone. And things are jumping straight into the next step quite lovingly. So dy upon dx is equal to the limit as delta x is mapped onto 0, and I have 1 upon delta x outside here just looking in, waiting patiently for its moment to actually strike. So this is that, and I have x plus 2 bracket x plus delta x plus 2 bracket. And it's time for delta 1 upon delta x to make its finishing move. Slash. So you're left with minus 1 at the top. Hey, yeah, so we can now substitute in delta x equal to 0, so I have this is equal to, maybe I could actually write this, dy upon dx is equal to minus 1 over x plus 2. Now since this is going to be equal to 0, what I'm going to say now is x plus 2, which means I now have to expand that out, and when I do, I will have x squared plus 4x plus 4. And that's it. Now if you remember this simple step here, it saves you a lot of time. Alright, I am not going to work number 10 as I did in the other video. I think a lecturer should break this down to the best of abilities, and if you have a question, I could probably find some video that could probably assist in understanding this particular component there. Alright, so the very final question. Let me see my time. 58. If I probably just did it out, I probably completed it within an hour or less. But alright, we are here. Minus 2 over 2x minus 1. F of x is equal to minus, open bracket, 2x minus 1. So dy upon dx is equal to the limit as h approaches 0 of minus 2 over 2x plus h minus 1. I got right it out. Minus 2, yeah, I got to tell myself to do some things because I was just going to jump to the next step. And this is all being divided by h. So my next step, I'm going to put h out in front. So dy upon dx is equal to the limit as h approaches 0 of 1 over h. How am I doing? This needs to, I'll just stick to that. Of minus 2 over 2 over bracket x plus h minus 1. Alright, so, oh lovely, I need to always remember that. Use your bracket so you could pay attention to that. So it's going to be positive now. 2 over 2x minus 1. We can make this larger. Alright, so I'm going to have to work this here out. Alright, so what I have is, alright, I need to just look for a moment here. Alright, so let me just put a small in front. 2x minus 1. I'm going to put this in a square bracket. 2 of x plus h close bracket minus 1 square bracket. So in working this out here, I'm going to have this minus 2 being multiplying what's here, because this and this will cancel out. So I have minus 4x plus 2. Alright, so with this here canceling each other out, I'm going to be left with this here. So this is plus 2 times 2 is 4, open bracket, x plus h, close bracket, minus 2. So I'm just going to get rid of that one time. Makes my life so much easier. Alright, so I'm just going to I'm working out this part here, right? So this is my focus as I'm going to write it out now. Minus 4x plus 4x plus 4h. Right? So this will also go. So just this here I did to just simplify. I didn't really feel like writing another line. So in finishing off, come on, okay, great. In finishing off is equal to the limit as h approaches 0. Remember, out front we have the 1 divided by x. So it's 1 over h, sorry. 1 over h. Yeah, the joy of finally actually completing all of this. Of 4h, all being divided by. I'm going to choose to substitute now. So I'm going to have 2 open bracket 2x, sorry, minus 1 bracket of 2x plus 0 minus 1. So this h is going to tell this h it's time for us to leave. So this is equal to the limit as h approaches 0 of 4 over 2x minus 1 times 2x minus 1. So my final line for dy upon dx is equal to 4, and I'm going to expand this out. So it's going to give me 4x squared minus 4x plus 1. And that's your wham bam. Thank you. Ma'am, everything is done. I could finally go and get something to eat and prepare for my other activities for today. This year, as I said before, I'm going to leave this to start to explain to the class. And I hope this video has found you well and you do enjoy the remainder of your day.